Hi Algebra 1, welcome back to class. Today is our last video of the week. Woohoo! We are going to be moving into 10.4 and that is on page 620 in your books. And you definitely need your books today because one of the problems we're going to be doing together is a word problem. So I didn't write that out on your note handout and I'm not going to read it out for you on the video either. So make sure you have your book with you. Note handout today, available on RunWeb, or at least paper and pencil as we go through today's lesson. Today we are going to take everything that we've been learning about radicals and we're going to apply it to solving radical equations. Okay, so far we've been simplifying radical expressions. Remember, an expression is where there's no equal sign and I can just clean up using all the rules I know for algebra. As soon as I throw in an equal sign, that means I'm actually going to solve it and I'm going to get a value for the variable in the problem. Okay, so today we're going to start really basic. Radical equations are equations that have equal sign and a radical. Pretty simple. Step one is to isolate the radical. The first thing we want to do is to get my radical alone. Just like when we're solving for variables in our simpler equations that we've been doing all year, we want to get the variable alone. Well, before I can go through any of my processes here, I need to get my radical alone. So in this first problem, what I'm going to do, because I see my radical is here, I want to get that alone. So I'm going to subtract 7 from both sides. Keep working down. There's my equal sign. I know I did the right thing when those cancel out. So I'm left with the square root of x equals 9. Now at this point, most of you are like, I can do that in my head. I want you to get familiar with the process here because the problems are going to get harder. Okay? Step one, isolate the radical. It's all alone on one side of my equation. I'm ready to go to number 2. How would I undo this radical? Remember, the way we solve equations all along is by doing the opposite operation. Addition, we use subtraction. Multiplication, we use division, and vice versa. Well, in this case, if I have the square root, how do I undo a square root? We undo a square root by squaring. And if I square one side, I have to square the other. This cancels out, giving me just the x. And it gives me 81. Okay, like I said, we're starting really simple. To undo a square root, we square it. And so that actually cancels that out, giving me just the radicand. 9 squared is 81. Step 3 is always check. Now I can do this mentally. If I say x is 81, I go back to my original equation, the square root of 81. And in this case, remember that discussion about the principal root. This is where it comes into play. I only want the positive version of the answer. Square root of 81 is 9 plus 7 equals 16. Check. That means I got the right answer. Okay, I want you to pause the video and try this problem, and then we'll come back together to go over that and get to add a little more dimension to these problems. Okay, pause the video, try this one, and then we'll go over it. Okay, remember, step 1, isolate the radical. I want to get that alone. So in order to do that, I need to add 5 to both sides. I know I did the right thing when those cancel out, leaving me the square root of x equals 3. How do I undo my square root? Well, I square both sides. Because remember, I can do anything I want to an equation as long as I do it to both sides or do it to everything involved. That leaves me the radicand and I get x equals 9. Step 3, always check. Take that value that I got for x, go back to the beginning. Square root of 9, I want the principal root, so it's 3 minus 5 equals -2. Check. I got them right. Okay, for our next problem, this will be problem 2 in your books. That is the word problem on page 621. So I need you to turn there. I wrote out this formula that somebody much smarter than me came up with when you're talking about clocks and pendulums. So if you think of an old grandfather clock where there's the pendulum marking the time, you'll notice they have different lengths of the pendulum. We're going to be talking about that. L is the length of the pendulum. T is the time in seconds it takes for that pendulum to do a complete swing there and back. Okay, so this formula is time in seconds equals 2 times the square root of the length divided by 3.3. Like I said, somebody a lot smarter than me has already figured this out. Our question is asking, well, if it takes my pendulum 3 seconds to complete a swing, how long is the pendulum, or what is L? What is the length? So I go ahead and I plug in what I was given. T equals 3. I'm going to take that T out and put in 3. The question is asking, what is L? So you notice I'm trying to solve for L. I'm trying to get that alone. Well, I need to go through some very specific steps in order to get there. So the first thing that I see is I have 2 times this radical. Well, we already talked about that. My first step in solving radical equations is to isolate my radical. How would I get rid of that 2 so my radical is alone? Well, if 2 is being multiplied, I do the opposite operation. So I'm going to divide both sides by 2. I'm going to show you that here. I know I did the right thing because 2 divided by 2 is 1. I got rid of it. 3 halves. Okay, I'm going to use my eraser because I have a whiteboard. 3 halves equals this square root. Now, if you look in the book, they go ahead and say, well, 3 halves is 1.5. You can do that, 1.5. You can totally do all of your work here using a calculator. You're going to need it eventually anyways. For the sake of algebra, I'm just going to leave it as 3 halves. So hang with me and see how this works out. Step 2 of solving a radical equation is to square both sides because I want to get rid of this radical. So the opposite operation for a square root is to square it. Now remember, I can do anything I want as long as I do it to both sides. So let's see where I stand. I now have L divided by 3.3 because that's what was underneath my radical. And I have 3 halves squared. Go back to what we learned for our power rules. If I have a quotient, a fraction, being raised to a power, that means I square the numerator and I square the denominator. So I'm going to leave this as 9/4. Hang with me. Okay, remember, you can use a calculator at any point along this pathway here. My last step, because I want to get L by itself. That's my ultimate thing I'm trying to solve for. Well, L is being divided by 3.3. So how will I get it alone? Do the opposite operation. I multiply by 3.3. Well, I know I did the right thing because that cancels out, leaving me L. If I multiply this side by 3.3, hang tight with me, I'm going to squeeze in here. 3.3 times 9/4. Okay, I need my calculator anyways at this point. So 9/4 is 9 divided by 4, which if you did that on your calculator, you get 2.25. Multiplied by 3.3, let's see, what do we get? We get 7.425 as the length of my pendulum. 7.425 feet. Now, let's see. The problem in the book said round to the nearest 1/10 of a foot. So my final answer would be 7.4 feet. We're talking about a really big clock because the length of the pendulum is taller than all of us. Or each and every one of us, I guess, technically. Okay, so this is a very large clock. All right. The practice problem for this one says, solve the same exact problem. But in this scenario, what if t equals 1 second? So our t for the original problem was 3 seconds. So it took 3 seconds for this pendulum to complete a swing. Now, if our time is down to 1 second, let's just think about what that means for the length of my pendulum. If my swing time is going to be shorter, what does that mean is going to be true about the length of my pendulum? Am I going to have a much longer pendulum, or am I going to have a shorter pendulum? So think through that as you try this practice problem. Pause the video and come back when you're ready to go over it. Okay, as you can see, I'm just erasing this, and I'm going to plug in. Let's get back to where we started. This time, I'm told to say t equals 1. There was a 2 here in this equation, and I'm going to erase this too. Like I said, I'm going all the way back to the beginning. I'm still doing the same process, and actually, I probably could have left a lot of that up on the board. That's okay. I want you to be really sure you're understanding this process. Okay, so my time in this problem is 1. Remember, we're not doing that problem, we're doing the practice problem. T equals 1 second. It equals 2 times the square root of the length divided by 3.3. We're going to do the same process. Remember, I'm trying to get L alone. So my first step to solve this is to isolate the radical. Well, I have this 2 out front. So to get rid of it, I want to divide by it. Opposite operation, if I divide that side, I divide the other side. I'm going to get rid of this for the sake of space. So I have 1/2 equals this radical. Well, step 2 for solving radical equations is to square both sides. The opposite operation to square root is squaring. And if I do it to one side, I do it to the other. So 1/2 quantity squared gives me 1/4. That leaves me with L divided by 3.3, because the squaring of the square root cancels that out, leaving me just the radicand. Well, my last step is, if I'm dividing by 3.3, to undo that, I do the opposite, which is multiply by 3.3. I know that cancels out, leaving me my L, which is what I'm trying to solve for. So I take 1/4 times 3.3. Pull out your calculators for that, and you would have gotten, let's see, where's my answer? 0.8. And I'm going to leave it there because the problem said to solve to the nearest 1/10 of a foot. So if my time goes down to 1 second, the length of my pendulum shrunk to less than 1 foot for this problem. So think back to when I was telling you to think through this problem. Does that make sense? Shorter time means a shorter pendulum. Sure does. Okay, the next part of our lesson, I'm going to clear this board and we're going to do some more difficult, involved radical equations before we call it a day. Okay. So this time, we're going to be dealing with what to do if I have a radical on both sides of my equation. And you'll find that actually, you don't need to be intimidated by these at all. They're still pretty easy. So I'm putting up one practice one for us to do, or one problem for us to do together, one example, and then one practice problem. I hope I left enough space. I think I did. Okay, so this time I have radicals on both sides of the equations. I have the square root of 5t minus 11 equals the square root of t plus 5. Okay, what do I notice is different? Besides there being a radical on both sides, I notice that I have a quantity as my radicand. I have more than one term underneath my radical. For these types of problems, it actually doesn't change anything at all. Okay, step 1, do you remember what it was? Step 1 is isolate the radical. Well, if I have 2 of them, I can only isolate one of them, and for the sake of these problems, they're both already alone. Great. Step 2, square both sides. By squaring this side, I'm undoing that square root, and by my rules for solving equations, I have to do that to both sides. Well, the nice thing that happens here is it actually takes care of both radicals. So I'm left with my radicand on this side and my radicand on this side. Well, this turned into a really nice equation. Ones that we wish we still had to do for math homework. I have a variable on each side. That means I need to do my use my equation properties to move numbers to one side, variables to the other. So I'm going to subtract t and get 4t. In the same step, I'm going to add 11 and get 4t equals 16. T equals 4. Nice. We like those. Step 3, check. Take that value for t and plug it into the very original problem that we started with. 5 times 4 is 20, minus 11 is 9, square root of 9 is 3. 4 plus 5 is 9, square root of 9 is 3. 3 equals 3. Check. It works. Okay, pause the video here and attempt the second practice problem with radicals on both sides of the equations, and your steps still apply. Step 1, isolate the radical. Step 2, square both sides. Step 3, solve and check. Okay, go ahead and pause the video. Come back when you're ready to talk about it. Okay, step 1, isolate my radicals. Well, they're both isolated. I just happen to have 2 of them. Step 2, square both sides. Now, that squaring undoes this, and it undoes this. It's weird grammar for math. Okay, leaving me just my radicands. Now we have equations that are just multi-step equations back from the beginning of this year and you learned last year. Don't you wish algebra was still this simple? Well, you get a little break. You have a little bit of it right now. Okay, I want to get all my x's to one side, all my numbers to the other. So if I do that, I'm going to subtract 5x and add 4. I can do both at the same time, right? You guys can handle that. I get x equals 7. I don't know that I'm completely done until I have checked that. I take that value for x, plug it back into the beginning. 7 times 7 is 49, minus 5 is the square root of 45. It's not a perfect square, but hang tight. Over here, 5 times 7 is 35, plus 10 is 45. Oh, look, I have the square root of 45 equals the square root of 45. That is true. Okay, that is it for today and this week. Guys, that means we have 1 week left of Algebra 1 together. I'm sad, but I know you guys are really, really excited to be done with this distance learning craziness. Okay, so you have suggested book problems on the note handout and also listed on RenWeb. Ones to practice, to make sure you're feeling comfortable with this. And then remember, today's assignment is not on Khan Academy. Wednesday, Thursday, Friday are all on one worksheet on RenWeb, listed under Wednesday though. So there are 4 or 5 problems for each section that we go through. Actually, I have it right in front of me. 4 or 5 problems it is, 13 total. And that is due Friday at 5 p.m. Okay, that's it for today and this week. Have a great weekend. Bye-bye.